Hello and welcome to this learning session on the SPA2 configuration software. Today we are going to be focusing on the SPA2 high-level instrument, and we're going to be talking strictly about the input tab. We'll talk about the other tabs in subsequent sessions. Okay, so here we are. The high-level SPA2 is capable of measuring current and voltage. So in my input type, the selections I have, hang on, let's stop the unit before we go in there and attempt to make any changes. The input types I have available to me are current and voltage. And down here you see the different ranges that we have: 50 milliamps, 25, 12.5, and 6.25. Always select the lowest number that will be larger than what you are going to measure. So in my case, I want to measure 4 to 20 milliamps. So I'm going to choose the 25 milliamp range. That'll give us a little better resolution for our readings. Okay, and to go along with that, over here I want to absolutely define the upper range is 20 and the lower range is 4. Remember, it can go up to 25 milliamps and down to 0. That's why it has 0 and 25 populated there a moment ago. That's our complete range, and it's shown right here as well. Okay. And any changes I make on this page, if I want to commit them to the memory of the unit, I can hit this quick set button, and that will download them to the SPA2. Okay, so you've seen the input type and how to define your range. Now let's talk about some of these other things. Broken wire detection. That is defined by the user. You define a level at which you you're just going to say that's broken wire. The only time I'm going to get down to that level is if I have a true broken wire situation. So I'm going to enable that, and I'm going to say, hey, look, if I go down to 2 milliamps, I'm going to define that as broken wire, because my normal range is going to be 4 to 20 milliamps. If it gets lower than that by a significant amount, then I'm going to say, hey, broken wire. And that'll send an error message, put an error message on the screen, and also trigger things in the alarms you'll see later on for broken wire. Okay. Next one down here is the running average filter settings. You can enable that or disable it. It goes up to number 64 here on the highest. I believe it's 64. Let's climb up here, see what it says. Yeah, there you go. And what that does is, if you have an input that is jumping around quite a bit, your 4 to 20 is very, very jittery, and you want to smooth it out a bit, you can say, like I show here in my example, I put number 10 in the box. So the instrument is now going to take 10 individual measurements and then average them out and display that average value on the screen and use that for your analog output. So that'll smooth everything out. And it depends how jumpy everything is. You can, like I said, you can run it from 1 all the way up to 64, which would be a lot of smoothing there. And you can do that again. I made some small changes there. I can do the quick set to save those. Okay. Also here we have a filter setting, 50 hertz, 60 hertz, and fast. Now anybody that's running, say, in Europe where they have 50 hertz power generation, I would recommend using that setting. And the reason for that is, no matter if you're getting your SPA2 power from AC or from DC, there's always going to be, especially on DC, some amount of 50 hertz ripple that could affect the input readings. So by using that filter, we'll filter out most of that 50 hertz ripple that could be present, so you'll get a smoother reading. Same with the United States and in countries in the Western Hemisphere here that use 60 hertz. I'd recommend using that selection right there. And then, lastly, down the bottom, we have the selection for fast. If you have an application where you absolutely must read the input value as fast as possible, and maybe you got a very fast rotating turbine, and if it starts to vary a little bit, you have to know right away. You can't delay anything. You might want to go to the fast setting. And what that does is it allows the input of the instrument to be read at the highest possible rate. And again, notice when I hit the fast, I lose the ability to set running average filter settings, because you don't want that. You want it as quickly as possible. You don't want to have to average 10 input samples. So let's go back there. And I'm going to enable mine, and I'm going to put it back at something like 10, just for fun. And do a quick set on that, so it's committed to memory. Okay, lastly on the input tab, we have input trimming. Now, input trimming, you got to be a little bit careful. You got to know what your actual inputs are. If, by example, you're receiving 4 milliamps to the SPA2, but the SPA2 is reading 4.01 or something like that, you might want to trim it a tiny bit so that it matches your other equipment that you're using. But make sure your other equipment that you're using is as accurate or more accurate than the SPA2, or else you're just compensating for an error somewhere else. You're compensating by forcing an error into the SPA2. Anyhow, let's see how it works. Currently it's disabled. That's the way it is at default. You can use a 1-point trim, which will allow you to just choose any value between 4 and 20 and use that as your standard. And then when you have that input, say if I selected 12 milliamps, and then I would apply 12 milliamps to the input of the SPA2 and trim to that. And that will raise or lower everything that the SPA2 is reading. So if you're 0.1 milliamp off, and when you trim that, everything is going to change by 0.1 milliamp. 2-point is always a little better. 2-point, the best settings you could use here are 4 and 20, which are the endpoints that I defined up here. So I would apply a 4 milliamp signal to the instrument and trim at that, and then apply a 20 milliamp to the input and trim at that. So let's go ahead. I'll say set for that. Set for that. That'll put it into the memory of the instrument. And I'll go ahead and I'll put my 4 milliamps in, and now I'm going to say trim. So it's going to grab whatever is there, and we'll see what it finds in a moment here. There. What it found is 4.0002. So I have a pretty accurate input, but I now just trimmed it, so when I apply that amount to the instrument reads 4 milliamps dead on. Now let's go over to 20 milliamps. I'm going to change my input to 20 milliamps. And then I'm going to say trim to whatever you're receiving. Yeah, well there, you can see my test set is pretty good. It is, the 20 milliamp input is dead on. So now I'll hit that quick set. And we'll start the unit. Applied. Okay, now you see over here my variable. Remember I left it at 20 milliamps a moment ago. There it is reading that. Now I'm going to push my 4 milliamp input button, and we'll see what it reads. See how slow it went down? That's because it's doing an averaging. There it is, exactly 4.000 milliamps. So that was what the trim allowed that to be exactly perfect, at least for my input. Well, there you have it. That's the settings of the high-level input tab, and like I said, in subsequent learning sessions we'll talk about all these other tabs, so we'll know how to configure the SPA2 correctly. Thank you for listening.